a lot of it is, my personal favorite in terms of the UVM rules, specifically in terms of the race conditions, reusability, performance, etc. However, we wanted to stick to the assertions part for most of it today. So yes, we did digress a bit from the agenda. Sorry about that, but we do want to show you that SVA is not, the only thing that we can do with the lint. As Himank kind of alluded to, if you recall the previous presentation. So the overall entire system Verilog is now available for you from the parser. So you could write rules on the wide spectrum of the DPI, assertions, RTL, your synthesis related, DFT related, and of course assertions and UVM, right? And the constraints and coverage. So depending on what you really want to check for, you could do that. So I would take over from here. Actually, this is all the work of Ajita and team, but I'm going to have the pleasure of presenting it, the SVA lint rules. Thanks, Ajita. And a lot of credit goes to Ben Cohen, who's a co-author in most of our books. So let me share my screen. Shared yet. So, okay. Let me know when you see it.
Yeah, it's
I'm still struggling to go back and forth between these. Sorry, I'm using an extended monitor, so this is one. I think. Hold on, almost it. Hold on. You should come up. Okay. Yep. I do have great folks helping me here with the stuff with the logistics. Thank you, guys. So yes, so as I said, this is all mostly Ajita's work, but I take the pleasure of presenting it. And this would be the main, what we wanted to start off on the assertion part. And as I said, a lot of it is derived from various books and materials available there. And we're just going to bore you with about 10 rules. And all of this is available for free forever on our GitHub. You can download it today and you don't have to tell us. You can use it as much as you want. And of course, we would love feedback. We would love to work with you and build more and of course, make money out of it. Fair enough. So this is the overall thing. I think a lot of this is going to be covered by Balaram. So let me go with my stuff, which is specifically into the assertion linting. And I'm going to start simple and fair. I'm not going to complicate, why we need this. And that's the best part of BIOL. You do not like this rule, you don't have to use it. It is unlike your commercial platforms wherein they give you 120 rules and say, there's a whole lot of noise in there and you go and filter what you don't want. This is for those who have been in verification for long enough, you would know there was a specman versus system Verilog. The specman did infinity minus, meaning everything is random unless you put a bang the front. Those who are old enough to remember specman, you would recall. Whereas system Verilog did the other way around. Unless you declare rand, it doesn't actually get randomized. So why do I say that as a totally unrelated example is how the commercial linters work versus open source today, especially for the test bench. To be fair, there are not too many options today, unfortunately, available, at least to my knowledge, on the commercial test bench linting. Having said that, the approach we take is quite different. We do the 0+. We don't give you 100 rules and say, go and filter what you don't want. We give you some, and it's what we call as a minimalist set of rules. And then we ask you to innovate on top. One customer asked me, okay, what if I build more, would you support? The answer is, if you build it, you got to support yourself, right? So of course, if we build it, we'll be very happy to support. In rare cases, if you do build and then you want us to take over and maintain it for you, we would be happy to do. So what I'm showing you in these rules is not something, it's not like a Bible thing, being a Sunday, if some of you are following that, right? So point is, we're not here to say, dictate what you should do and what you shouldn't do. But here are some of the best practices. Always use the fail action block. You may ask me why. And by the way, the intermediate pictures that you would see is all, if you haven't guessed it or if you haven't found it, it's all Bing AI image generated. It is not a copyright protected one. Okay, so SVA has dollar error as the default. So why should I even bother to override it? The reason is a lot of you are using UVM, and unless you have post-processing scripts, again, most of you have it, but nevertheless, it is good to have control over your error mechanisms. So using UVM error, for example, or even a company-specific UVM error macros or APIs is a great idea because that gives you control over number of errors. For instance, when you're running regressions overnight or the weekend, right, you could run it, as many errors as you want. But let's say Monday morning or Tuesday, you start working and then you want to stop at the first or second or third, maybe the 10th error. So we don't really want to be stopping at the very first error, maybe at the second error, and then start dumping, things like that. All that control you don't have to invent because UVM has already done that for you. You could leverage on all of that if you start using an action block. You could also have your own, let's say, debugger come up using a callback. So it's a very, very simple rule. If you like it, retain it. And this rule is already implemented. This is a big one, in my opinion. A lot of these DDRs, the PCIEs, they do have these assertion written in terms of specific timing checks. These are not your setup and hold checks, to be precise, not your gate level. But even at a protocol level, you want to say that between a start signal and an end signal, you want to make sure, let's say, a specific amount of microseconds are passed, right? Or the latency is not more than some number, right? And it's not uncommon. Please go and do a GitHub Google search, if a GitHub search if you want to. You would find code like this, right? Which the problematic code that I see is the 1.1 microsecond hard coded over there. Other than that, the code is, I would say, is pretty happy, right? I'm not too happy about checking the clock periods and etc. unless you really want to do that, because there are pitfalls with assertions in terms of checking clock periods. But between two signals, if you want to check your time, absolute time, or the relative time between two events, we may guess go and do it. All we are saying here is please do not hard code the 1.1 microsecond into your assertion. Avoid hard-coded time values. And imagine that you want to write a grep or a fancy regular expression. It's going to be painful because you got to make sure it is not under if-def, it's not under a generate block, it's not inside your comments, so on and so forth. Use a parser such as the variable. It's very, very easy. Like Himang showed, it's about 10 lines of code to get to this error specifically, because the iter find all API with variable is extremely powerful and it's very, very fast as well. So the recommended solution here is to use parameters or tick defines. I do prefer parameters over the tick defines, but again, do not use hard coded because it is hard to maintain. Your next step probably is going to beat this timing, probably will make it to 0.8 microsecond or something like that. This one is coming from latest book from Ben Cohen. On the right-hand side, you see. So it's a new book that Ben has come up with, Fast Tracking SVA Through Exposure. And he has a nice chapter on generative AI. And when he reviewed these slide decks, and he said, look, Srini, a lot of people are going to ask you about generative AI in the session. Be prepared. So definitely the wise suggestion. And not that I have done a lot of it in this particular presentation, but we have done quite a bit of work on it. But point is, in his book, he has come up with these rules, right? Some of them are highlighted here throughout this presentation. So in the 2.2.2, it's a $25 book, so you can't ask for anything cheaper than that. And it's a personalized copy. It will have your name and email address. So please go ahead and buy that book for all you know. It's very useful. It's the latest book on the SVA. And has several coding guidelines, and some of it is now implemented as a SVA lint here. So the rule number 2.2.2 that you see there, instead of using a range and the antecedent, use the go-to operator. Here's a suggestion. And of course, he explains in very, very detail in terms of why you should be doing what is being recommended. And guess what? We could implement this rule in about 30 minutes in the SVA lint framework. And again, this is available in the public domain today. So the one that I think Himang was showing as a PR that he has just submitted probably less than 24 hours ago is to implement some of these rules. So the assertion shall start with a specific prefix. The property shall have a prefix. assumes will have something, sequences will have something, the cover property or the directives will have a prefix. Again, it's totally up to you what style you want to use, right? We're not going to be hard and fast on it. In fact, very soon, and we do have it in our internal or customer consumable version. You have a TOML file to configure all this. But at this stage, it is something as very simple rule that says your code will have a specific set of naming coding guidelines with a prefix or a suffix or something like a snake case versus camel case. That one is wonderfully alluded to by my friend Mark Lesser in his book on next level test benches. He has a very, very nice way of articulating why you shouldn't be doing this. And I was wondering who does that. And then interestingly, people do that, unfortunately, right? Legacy code you take over, somebody had done a snake case name, like with an underscore, so then suddenly you start putting camel case in there. It's not a good thing to do. So stick to one of them. It doesn't matter which one. And we do check. I think this is a rule that I think Himank implemented in the SVC case, for example. So the camel case versus snake case, do not mix it in the same code. That's a right. Use consistent prefix and suffix. Use named assertions. Use end labels. As I think Hema also alluded to, a lot of customer code that we see, they don't use end labels. And I wonder why, because it makes your life so easy and the code looks really, really clean if you use end labels. I generally reject the check-ins if I have the power and authority if they don't have end labels, just so you know. And we do put that into the gatekeeper checks. I know people get annoyed at that, but it's up to you. If you are the manager, if you have the power, please go and block it with your gatekeepers. Most important ones, your simulation performance. One of the main reasons why some engineers and managers do not use assertions in their main flow is it sucks. It slows down your performance like crazy. And it's nothing to do with the simulator or with your, really the assertion as a syntax, but it is the way you use it, right? So for example, if you have put unbounded range in the antecedent, you're going to, again, this is very detailed explained in the Ben Cohen's recent book. Again, another reason to buy that $25 investment for yourself. I'm going to get $0 out of it, by the way, but it's definitely worth of spending that time. And it's a small book. It's a PDF. So he has explained in great detail as to why you should avoid unbounded range in the antecedent, also the first match. And he had taken inputs from people like Ed Choney. If you know Ed, he's already retired, but he was one of the co-authors of VMM, the precursor to UVM. Some of you would know. And we were colleagues, me and Ed and others were colleagues. So in full disclosure, of course, he has given directions and details on why first match is a bad idea to use. Also, people like Eric Seligman and others. If you read their books, you would see why first match is such a bad idea to use. I'm not fully convinced on it, but that's okay. Again, it's build your own linter. You want to build it saying you do not want to use first match, we can do that. My personal favorite, a lot of people have done pass action blocks. It's a great thing to learn. I do teach assertions a lot. When we do that for experimentation, do it, but never ever check in a code with a pass action block. Again, please go and search on the GitHub. You would find at least 10 such examples, various repositories on the GitHub showing you pass action block. It's a bad idea to check in any code with a pass action block because at every clock, you're going to get a message. And then you start complaining that assertions are slowing down my simulation, right? Thankfully, in System Verilog 2012, which is what 13 years old by now, unfortunately, right? So you would find an assert vacuous off as a API, as a assert control task, but unfortunately, not many people know it. And some tools have done it by default, but nevertheless, using an pass action block makes it really, really performance poor code. So these are team preferences. Again, some of it, I just mentioned the assert vacuous off, by the way, assertion system tasks and the assert control. You want to use it, you don't want to use it, it's up to you. The first and second bullet, I do agree with Ben. Again, these are all in his book, in the latest book that he has. Avoid within operator, avoid throughout operator. To some extent, I would agree, and to some extent throughout, I love it. I personally love it. Sorry, Ben, if I don't agree with you, that's okay. Same with LTL. I love them. I think I'm going to talk about that with some more examples as we go along. But I prefer the LTL operators because they are a lot more cleaner and succinct to use. But Ben says don't use it. Again, I'm not going to fight over it because if you're a paying customer, I would do what you want, right? Again, from your team perspective, whatever you're comfortable with, go and use it. And the best part is you could build a linter, almost a very thin layer in about, let's say 2-3 weeks, and then make sure your code is in line with what you want as a project lead. Similarly, weak and strong sequences, it's a big topic, but some of you would know that SVA has by default weak sequences, and you can make them declare them as strong if you want to make sure you do want completion of your threads that you have in your simulation when the simulation is ending. So if you want to use that, all the sequences on the consequent shall have a strong operator around it. Okay, yeah, there is an example of LTL. So yes, I do disagree with Ben on the specific examples and stuff. Again, it's something that it's a good, healthy debate to have, no problem. So my point is, again, I'm not going to read the entire code and as well as the spec and the waveform. That's for, as we say, it's a Sunday afternoon exercise for anybody who want to do it. But what I want to focus is a top right corner. I don't want you to be an engineer wearing a tie and then having a headache over this code on the waveform. And the worst part is this whole code still doesn't work. You wrote something, sig1, #0 first match with some $1:$, and then $1 fell, and then whatever, sig1. And the worst part is it still doesn't work for all cases. What we are saying is you could actually break this down to multiple assertions and then use LTL operators. Bear with me again. This slide will be with you if you want to spend more time on a Sunday, next Sunday afternoon, please do. But let's move on. So what did we do? On the top left, you see the same specification. We broke them down to multiple assertions. And this is the great coding guideline in formal verification. Do not write a fancy complex assertion like you see on the top right corner, just to show others that your prowess in SVA. Instead, break them down to the bottom two ones. There are now three assertions over there. Excuse me. Signal shall be 1 during request. Signal shall be 0 during a request fall. And then on the focus that I want to show you is the bottom right corner. If it's SVA 2012, again, as I mentioned, by now it should be default, but nevertheless, a lot of tools do have a switch to enable the until or until with operators. So I claim the until with, which is what you see at the arrow there, the SVA 2012 one, is a lot more cleaner and easier to read than the one that's at the bottom, which has the consequent you have a $0:$ with a #0 bang request. It does exactly the same thing, but I claim that until with is a lot more easier to interpret, to maintain. You don't have to explain to many people. Signal shall be low until the request comes back. Okay, so this is the poor slide. I will agree that, and we just didn't have time to complete it, unfortunately. But again, this is coming from the book, if you could guess. So 2214, it's again from the book. Do not use $0:$ excuse me, on the consequent, because an assertion with an infinite range in it consequent can never fail, but can pass. So it is probably a good thing to have it in, let's say, at the worst case as a cover. Again, there's another rule that says do not ever use an implication operator with a cover, keeping that as an aside. But if you put a $0:$ on the consequent, which will never fail, what is the point of writing an assert? An assert is expected to catch things that would fail. So please don't do this. There are other ways to code it. Again, this is something in great depth described in the book on the 2214. Again, this is something we would be able to implement very fast. I don't know if it's already implemented, but Ajita can correct me if I'm wrong. Okay, again, some of it is okay. That's here. So this is from 2024, as you can see it. So do not write this cover property. Request implies act. It's one of the stupidest code to write ever, because the problem is the vacuity triggers in, and then your cover coverage model comes back and says the report says all covered, even though you never triggered the request. Do not want to have that. So again, I'm skipping through some of it. Again, this is all on me. I haven't completed the slide in great style. I'm sorry about that, but we just didn't have enough time to do it. That's my excuse. So bear with me, sorry about that. But this is an important slide. That's why I wanted to retain it. Some EDA tools, which I will not name them, but if you dig enough in the Verification Academy portal, I think Ben Cohen reported this sometime back. S until with is not supported if it is in the consequent. It works in two tools. It doesn't, or it works in two tools. It doesn't work in two other tools, right? So depending on excuse me, which simulator you use, your code may or may not compile, and you do not want to be in that situation being an end user. So these are things that you can easily lint. And think about it. This is what we have been taught as lint in RTL long back, and we are now doing the same thing for SVA. Okay, so this is naturally leading to the next topic that Balaram is going to do more and more, but very high level. Some of you probably know what is Verilator. It's an open source simulator. What many of you probably do not realize is Verilator has fair amount of support for concurrent assertions, including temporal. My friend Balram will talk in detail about specific examples to the tune of AXI stream VIP, formal verification IP. But very high level, we did identify, this slide is going to come back, I think, in Balram's presentation, but I'm just stealing the show as I did with Ajita. I'm also stealing one slide from Balram to say that these are the rules we identified so far for validator support in SVA, and then we now can start coding them as lint. It's not something that is available yet, but this is something we are working on. Again, you can imagine that some rules are implemented using variable, some are implemented in PySlint and Slang, and I'm not going to make a comparison. We are going to work with all of it. In case you want to do it on Wordy or some other parser, Verific or anything else, we are very happy to do, because our architecture, as Ajita was showing you in the one of the slides, and we got good feedback from companies in Bristol without naming them. Thank you, Peter and others, who has given a valuable feedback on these lints. Wherein from the UK ecosystem, we did get quite a bit of feedback to say that do not tie your linter to a specific parser. Srivatsa told us to. So we listened to all of you, and then we did implement it in such a way that it is, I would say, parser agnostic. I wouldn't say independent, but it's parser agnostic. We do need a parser, but we can be agnostic to a parser, and the rules can run on any parser that you want, including commercial ones. Okay, so that's one slide on marketing, if you don't mind me doing this. One quick slide. What do? We do develop EDA flows, as you have been seeing it. We also deploy AI and ML. Nowadays, if you don't have this, nobody listens to you. So we need to have it, but we are serious about it. We do have quite a bit of machine learning APIs in the UVM inserted. It's called GoToUVM. Some of you have seen it. So we can collect a lot of information in terms of your run metrics or your coverage metrics and etc. and your log files in the machine learning enabled UVM library, which will drop in replacement and then start giving you insights on how you could efficiently run your regressions. We also do a lot of open source. You've been seeing that people have been wondering, how the heck are you eating, right? So if you do so much open source, where is the money, right? So we have our own ways, so I'm not going to talk about that. But of course, we need more money. And since 2004, we have been doing training. Ajita started this company called CVC back in Bangalore in 2004, and I joined in 2009 with her. So we have been doing a lot of training, and we do bring that to the UK customer. And that's kind of my one slide on marketing. I'm going to allude to the next presentation from Balram, but very high level, what we are saying is open source is now ahead of commercial EDA. I know it's a bold statement, and people say, why are you shouting? I mean, especially in UK, if I put anything in bold, we get, why are you shouting at me, right? The ahead is in bold, and we are shouting because we believe we are way ahead of, if not way ahead, at least ahead of commercial tools when it comes to SVA linting, right? Prove me wrong, I'm happy. But what we are saying is we are now ready for prime time deployment, and you can use custom lint to check your own code. You don't have to pay anybody right now. Go and download it, use it. Of course, the moment you want more, we would like to get some business. And the formal friendly SPA can actually use uses tools for formal property verification. So the big names that you know on FPV, of course, uses no replacement per se, but open source solutions are emerging, and my friend Balaram will take over from here. And yes, I'll take over more questions Q&A towards the end. Thank you. Balaram, floor is yours.
Hello.
Yes,
Hello.
Balaram, please share your screen.
Able to hear, right?
Yes, please share your screen, please. Hey, Balaram, we can hear you.
Yeah, I'm sharing.
Thank you.
Mhm. So, you able to see my screen?
Not yet. Not yet, unfortunately. We see you though. I like it.
But
Click on the share button if you want. Or I can share it for you if you want. Are you able to share your screen, Balaram?
yeah,
yes.
This is all right.
Thank you.
So, yeah, hello friends. This is Balaram and Balaram Nayak, and yeah, I'm associated in experimenting this open source with the Srini. And Srini, as we go, I think couple of presentation they've gone through the entire how they are operating all these things. But before that, also I did some open source experiment in UVM linting, SVA linting, and all these things. So all of I'm presenting here is SVA VIPs. That means any standard IP has their own VIP, and VIP has their own assertion, and we are porting into the open source tool called Verilator. So that's what I'm presenting today, and I'll go through a couple of slides. So my presentation goes introduction and SVA and how we are porting into the Verilator, and there are a couple of methodologies to tweak and fork and embed into the design, and port all the standard APB, AHP, AXI, SVA VIPs into the Verilator, and also associated with some unit test checking, and which enhance your debugging and better integration, and also we enhance into the AXI SVA VIPs into the Verilator, and with this two plugin called UOSS, and also we have built in your own linter, and we have a couple of rules to embed these SVAs. So I'll go through this agenda. And as Srini already explained about as we go, I won't go much into that. And and they are UK-based design house and EDA startup, and which has a lot of solutions right from the training to the advanced EDA support and services and whatnot, everything. And they are eventually going to the Gen AIs to plug in, and maybe in coming days they will come up to the all visual studios and get into all kind of all kind of EDA process into one place. And this is already Sinigon, EDA and AML training, open source, what they are doing, and won't take much time. So my interest is here. There is a AMBA architecture, you all know, there is a right side, and there is a processor, there is the internal memory and external memory and DMing, and there is a bridge and there are peripheral. This is any architecture subsystem you see, this is the architecture you see. So in that, what we are doing here is entire subsystem we are compiling and simulating in the Verilator. So in order to do that in this process, we are taken SVA VIPs and plug into the Verilator. And we have some unit checks, which is driven from SV units, and also entire process in a standard mode we are doing this. So this is how the SVA linting, how SVA linting works. So keeping this in mind, I'll go through a couple of slides. What is our approach to reach there? So we have SVA code, which is subset of Verilator, and we have some unit tests which can debug easily, and also we have some SV waveforms. This is the new log-based waveform debugging. We have typical traditional waveform debugging, but this is a log-based. This is very pretty, and we have some open source VCD and GTK waves to debug the entire flow onto the subsystem. So this is our approach. So if you take this as an example, how we are plugging these SVA VIPs into the Verilator. So I'm taking this as an example as a APB assertion. What we have done here is you can just download anywhere you will get, but you can write set of assertions, and this is the protocol, APB protocol. Let's say this is an ideal state, typical protocol as address and data and some control signal, ideal state, and setup stage and data access stage. So the difference between this is a set of control signal. So based on the P select and P enable, we switch into the ideal state or at the next stages. So this is pretty simple protocol, and there are set of rules how the requirement covered here. This is an assertion. So let's say you are in an access stage, the next state is ideal state, otherwise you have to go to the setup stage where you could, when you are in data stage, data access state, you have the status, you go to the setup stage or ideal state. So this is how the protocol checkers covered. And this is coming at part of this package, SVA linting package. So how we are plugging in and what is our results, I will go through now. So this is anti-sand, and this is the typical protocol structure, how it is covered. So this is the protocol, and how it is exactly SVA linting, how it is written as a unit test. If it is wrong, then it will cover as a part of these checkers. And this is a SV waveform where we have the the log-based waveform structure, and this is how it will show. If you plug in everything SV wave in your simulation process. And this is the sum of the results. Eventually all the assertions are passed, then it will show like this. And this is how it is. Some are failed and passed. This is how it compiles. I will share the link at the end and see how you can experiment with this and try to embed into any of design and see is there any issues. So SVA support to the Verilator is coming very new, and it is not 100% portable like any traditional EDS simulator, but if you do little tweaks and you can actually almost 90% you can match to that. So what you have to do in order to support your all SVA checkers for the Verilator simulator is a little bit tweak. For example, this is the simple protocol, and you have to write in such a way that it has to, the simulator has to understand. So setup, if you see the property which is covered and verification directories is covered, signal functions, implication operators, all this is covered. There are certain things which is not covered in Verilator is default disable, which is it's not easy to implement, but it is coming up, but it is not covered right now. And sequences, the properties are covered with little tweaks, but sequences are not covered. The difference between property and sequence is like the clock-based operation was not there. Sequences eventually trigger anytime based on the implication operation. So, and one count, unknowns, one heart, all these are covered, and this is how we have to write the protocol. So I will show the difference between the traditional SVA checkers and the Verilator acceptable process in next slide. So for example, we ported this AHB SVA VIP into the Verilator, and you see, and most of this is covered in Verilator, and some are we need some workarounds, and property asset in out of 26, 20 covered, and 6 needs little bit workarounds. So I will show you a couple of workarounds you need to tweak. If you are very finding a difficulty in getting those errors, then you can just ask same assertion how we can write in a different way to the ChatGPT, and ChatGPT or any other tool will give you the different ways to that, and just cut and paste that and it works. So just a way of writing. I will show you a couple of examples, and we're pretty much integrated into the AHP AXIs, and this is are the results ported into Verilator, and recommended properties are compatible. So not all SVAs are supported in Verilator right now, as I said. Some have needs some workaround. So let's see what kind of workaround we need to this. So for example, this is an assertion in AHB when we have edge response, and the next clock cycle trans has to go 0. So it's a similar way. So instead of writing checking this into the one clock later and then checking H trans, we have to do little tweak to this, saying in the past we have to make sure that the H response is high, and the similar. So the difference between this is just checking in the past. That's a small thing we have to tweak, and the same way for the XI kind of thing where we have valid and edge ready, and you have to use this kind of operator to make sure that it accepted in Verilator. So small things we have to make sure. I think in the coming days it will come along with the any of our any of the area tool works, but right now we have to do little tweaks so that it matches 100%. And I will show what are not covered here. Yeah, so there is a YOSIS is a synthesized open source synthesized tool, and which has also embedded with all the formal property verification. So the formal property verification has many checkers which is originated through this YOSIS, and out of 21 properties, 18 are covered, and 2 need some workaround, and some are in the progress to be done. So assets are out of 30, 22, out of 27, 19 are covered and further cover. So pretty much it is covered actually. And all SVAs are ported into the Verilator, identified, and some unsupported. And we recommend using these properties into the Verilator. And if you are very passionate about exploring the open source, so what as a open source community recommends is you experiment this. It's all free, so take this and experiment this, and if you have any issues, post there and they will fix. And 2 years before, when I attended these kind of conferences and that time it was not matured, but after 2 years it's very much matured and coming across, and almost 300 issues found recently, and they are keep fixing, and it's getting really mature. And students who wants to use their time with this is excellent place to play around. And that's how I got interested in looking this. And this is something built your own linter with a Verilator. So you have Verilator, you have your own design subsystem. What we are doing is on top of this entire process, we are plugging this SVA linter. So what we have done is there are lots of almost 50 plus SVA projects are ported into Verilator, identified almost 12 SVA linter rules, and rules implemented on the Google. So these all in the background we have this variable and pious lint from the as we go, and variable from the Google. They are the parsing tools which will parse entire your assertion checker and keep in a manner where it has to be compatible with the simulator. So this is how all overall structure works. And as if you go to the rules, so if there is no delays. So this is how we use, instead of delay you have to use the past. This is all I showed the example. And no delay range, there is not supported at, and no repeated, this is not implemented the consecutive operators and equal. So there is no sequence is implemented yet, except that you have to do little bit tweaks in this format, but otherwise I think 95 to 98% it accepts all your traditional way. And so summary, we are proven as a startup now ready to your prime design verification. SVL linter checks your code, and which is almost 100% compatible with the Verilator, and formal friendly SVA checkers are implemented using this YOSIS synthesizable platform, synthesizable platform. This is all what we have done in terms of SVA plugin into the Verilator in your any of subsystem. If anyone wants to explore, get the GitHub link and then try to explore in this format. So let me know any questions. Hello.
Thanks a lot. Can you hear me?
Yes.
Yeah, Balaram, thank you. Yeah, actually, if you could leave the last slide open, we could open up our Q&A. I think I like the way he concluded it, especially on the Axis side, and on the Verilator side. As Mahatma Gandhi is one of the famous quotes, "Be the change that you want to see." Right. So if you want to have more and more support in Verilator on SVA, please feel free to contribute, at least test cases. If you are a C++ engineer, please spend some time trying to add features to it. So that's the only way as an industry we can move forward, and we can have more and more case studies, maybe PCIe's, the USBs running on Verilator with assertions, and even formal verification with YOSIS and so on and so forth. So we all have some role to play than just saying, yeah, I want everything for free. Of course, we all have to contribute and then make it happen. We kind of thank you, Balaram. I know it's early for you and Himank, and it's late for Hema and others in India. Truly appreciate again. Most of you have taken, all of you have taken your time on Sunday, except if you're joining from Japan or somewhere. By the way, there was this RGGen author from Japan was also interested in this. So I hope that it was useful. We could take Q&A if there are people still interested. I'm all ears. Please unmute yourself and then ask questions if you want to. I'll give you a few minutes. I know it's a Sunday evening or even night for some, Sunday morning for some of you, and then Thank you, Martin. Thanks for your comments and appreciation. Yes, we do look forward to working with most of you. Any questions? Feel free to ask. Otherwise, we would wrap up. Any questions that you? Yes, please.
What's the roadmap?
Actually, it's a great question. I think Ajita's slide showed the. I know. So, I don't know if I have the slides. Ajita, in case you are there, if you could share. Otherwise, okay. Very high level, I can tell you that we are working on today. We have UVM lint, as you saw, about 95 rules implemented. It's not open source, just to be sure. Some of it is open source, some of it is not. So in our production, we do have about 100 rules on UVM lint. You asked me about the maturity. So UVM lint is probably the most matured product that we have. As a framework, we have open sourced it, but of course we have to earn our bread. Right? We have tummies to feed, right? So we do have teams in India and as well as here. So yes, so UVM lint is probably already in there at a couple of customer bases. SVA lint is being used actively. That's where Hema and others are actively deploying. In 8 hours from now, she'll go back to that. So we are deploying actively SVA lint. So those two are already in there. Of course, by no means it's done. We are just getting started. Few customer paid engagements we are getting in. And then there are things like emulation lint is coming in. So that's in the roadmap. We need contributors because I'm not an emulation expert, to be honest. And I do have a couple of friends who are helping us, but we do need more rules on emulation. Safety lint is another big one. We are interested, but we are not sure how much we can do. We've been looking at CWE's, the common weakness enumeration list, to come up with about 12 rules we have on the safety. Formal verification lint is another big topic. It's hard to get, given the commercial interest in all these formal verification products. It's very difficult to get a list out of the formal verification vendors to say that this is supported, this is not supported, or this would give dead ends, this wouldn't give you a dead end. This would give you an abstraction, easier abstraction than this particular style of coding. Not everything is style of coding, but whatever is related to. Unfortunately, we don't have that list. But we are actually working on a lint, I would say. That should come in about a quarter from now. I wouldn't say it's in deployment, but Ajita, correct me if I'm wrong, because some of it is she owns it. But then I'm trying to remember. Yeah, Yo-Yo lint is another one. I don't know if some of you are interested in Yosis as a synthesis platform, especially on the FPGA side. And if you're interested in using system Verilog with it, there is something called a Yo-Yo lint we put together. I would say it's a toy at this stage, but we are adding more. We are looking for, again, because Yosis is free, Yo-Yo lint is free. It's difficult for me to contribute a lot. Invest a lot in it, but we are looking for partners who want to take it forward to FPGA side. One thing that I do want to specifically mention about the FPGA part is we are now a partner with Altera. It's called ASAP, Altera Solutions Acceleration Partner. We thank Altera for it. That's the name. So with that, what we are doing is Altera has recently come up with the Agile 7 platform, FPGAs, wherein there are dedicated AI functions. So we are now coming up with the rules that would say, if you code your FDev and your specific DSPs in a specific way, it could map into an Agile 7 AI block than a regular LUTs and CLBs. That would give you a much better performance in terms of LUT usage, resource usage, as well as your timing. That's something we're working on with Altera and other partners, but it is not there yet. But that's kind of where we are heading. Thank you. Anything else? Yes, sir.
You mentioned that you are targeting the API, AML, ML API.
On the GoToUVM, yes.
So are you sort of calling this standard Gen AI?
No, we are not mixing AI and ML. It's an AI and ML is just, I think it's a rhyming thing. Beyond that, I personally, as an engineer, could not find much in common, honestly, at least so far I have not found it. There are two distinct topics. Machine learning is something that we are enabling through GoToUVM library, wherein when you run your UVM regressions, we collect data for the machines to learn. And then once it is learned, we can apply AI. To me, it's a two-step process.
But when you say an AI engine, are you calling something like something outside the whole verification infrastructure to go and then process and come back, or is it?
Not yet. I would say it's all pieces. The Go to UVM enables you to do data collection. That's why we call it ML. It doesn't have anything AI yet. But we do have AI plugins the other way, like Ajita was talking about. It's called supercharging your AI tools. If you have a ChatGPT or a cloud AI code generator that want to be, let's say, specific to a space grade FPGA, right? So if you want to know if, okay, you load your VHDL or Verilog and then say, okay, does this fit into an Actel FPGA or something, right? It may not. And that intelligence is not there very much with the AI tools today. So we are augmenting that through a custom, what do they call it? They call it plugin, no, not plugin. It's an agent or something. So there are specific, and we talked about it at the State of OpenCon earlier this year at a London event. That video is also available on the public domain if you want. I'll show you that. I'll send you a link. That we're doing a lot on the AI side with giving a linter plugin to the AI tools to do probably what you're asking, right? That would give you an AI generated code much better, value for money in terms of, outputs.
Yeah, but there is a security thing that you are running it
Fair.
in a VPN tunnel, which is within the company's framework. And if you want to call an external AI.
Not necessarily external, right? Because Cloud A can actually work in an air gap situation today. So you are right. So I think Meta, what is it called? Llama can be a private deployment. Cloud A can be private deployment. ChatGPT, OpenAI, yes, you are right. And we are not solving the problem. We are too small to solve the problem. Right? I mean, that's the problem that we are not solving, but we are not solving the problem. We know exactly what you're talking about. That is not a problem I am solving, unfortunately. I mean, there are other people who are trying to solve it, but we are not solving it. I mean, we would benefit from that solution, but yeah, we are in the same boat as you are. Thank you. Okay, I know it's late for you guys. Thank you. Truly appreciate it again. Once more, the recording should be public in probably a few days on the YouTube. Thanks, Rama, Hema, and others, and all the speakers, especially Himang, Balaram, Ajita, Hema. Thank you very much. We will wind up here. Thank you.
Thank you very much.
Leave on all devices in meeting.
Thanks, Dennis. Thanks, everyone. Thanks, everybody.